This is the OCR GCSE 9-1 Maths Paper 3 from the November 2022 series, and this paper is a calculator paper from the foundation tier. Question number 1. Reflect this shape in the mirror line. When we reflect this shape in the mirror line, we end up with this shape here. Question number 2, part A. Write these numbers in order of size, starting with the smallest. The smallest number is negative 20, followed by the 0.351, followed by the 10. Part B. Find the difference between the largest and the smallest of these numbers. The largest number is 304. The smallest number is 3.04. If we find the difference between these, we end up with 300.96. So the difference between the largest number and the smallest number is 300.96. Question number 3, part A. We have to insert brackets to make this calculation correct. 5 subtract 5 times 5 equals 0. Well, 0 times anything is 0. How could we get 0? Well, we could get a 0 by working out 5 subtract 5, and the result of 5 subtract 5 is 0, and multiplying that by 5, we end up with 0. Part B. Insert two of these symbols, plus, subtract, multiply or divide, to make this calculation correct. We want to end up with 0 as our final answer. Now we have 20, and then here we have 5, a 1 and a 3. Now I know that 20 subtract 20 is 0. But with this 5, the 1 and the 3, can we make 20 with that? Well, we can, because if I do 1 plus 3, I get 4, and if I multiply that by 5, I get 20. So this value is 20. And 20 subtract 20 is equal to 0. So we have a subtract here and a plus here. Question number 4. On the grid are 7 triangles labelled A to G. We have A, B, C, D, E, F and G. Complete each statement by writing the letter of the correct triangle. Triangle A is congruent to triangle, well, if I take a look at triangle A, the triangle which is mathematically the same as triangle A is triangle E. Triangle A is congruent to triangle E. Triangle B is mathematically similar to triangle. Well, if we take a look at triangle B, if we take triangle B and enlarge it by scale factor 2, we end up with triangle F. Here we have a distance of 2, here we have a distance of 4, here we have a distance of 1, here we have a distance of 2. Therefore, triangle B is mathematically similar to triangle F. Question number 5. Solve. Part A. X divided by 4 equals 8. If we multiply both sides by 4, then 8 times by 4 is 32. So, we have x equals 32. Part B. X subtract x equals negative 2. If we take to look to solve this equation, we can begin by adding x to both sides, leaving us with 8 equals x subtract 2. And now if we add 2 to both sides, we end up with 10 equals x. X is equal to 10. Question 6, part A. We have to write 28 to 70 as a ratio in its simplest form. Well, if we divide both sides by 14, we end up with 2 to 5, our ratio in its simplest form. So we have 2 to 5. Part B. A map has a scale of 8 centimeters, represents 1 meter. The scale can be written as a ratio in the form 1 to n. We have to find the value of n. Let's write everything in centimeters. We have 8 centimeters and 1 meter, and the 1 meter is the same as 100 centimeters. If we divide both sides by 8, we would have 1 centimeter to 12.5 centimeters, which means n is 12.5 centimeters. Question number 7. It takes a librarian 1 1/4 minutes to put a plastic cover on a book. Work out how many books the librarian can cover in half an hour. Half an hour is the same as 30 minutes. The units are now the same. We need to find out how many 1 1/4 minutes go into 30 minutes. And therefore, we would have to do the calculation 30 divided by 1 1/4. So if we work out 30 divided by 1 1/4, we end up with 24. So she can cover 24 books in half an hour. Question number 8 for part A. Complete this statement by writing a positive whole number in each box to make 2 different but equivalent fractions. Well, we have 2 over 16, which we could write, and what this will be the same as is 1/8 when we simplify it. Part B. Complete this statement by writing a possible positive whole number in the box. We have 1/5 being less than something over 10 being less than 1/2. One way in which we can do this is to write everything over a common denominator. The common denominator is 10. 1/5 is the same as 2/10. 1/2 is the same as 5/10. So what could go on the numerator over here? Well, we need a number between 2 and 5. For example, we could have 3. Or we could even have 4. And therefore, we would have 3/10. That's a positive whole number. Question number 9. A meal deal consists of a burger, a side dish and a drink chosen from these lists. We've got for burgers, hamburger or veggie burger. For a side dish, we've got baked beans, fries or sweet corn. And for a drink, we've got cola and lemonade. Part A. Some of the possible meal deals are shown in this table. Complete the table to show all the possible meal deals. You may not need all the rows. So we could get a hamburger, baked beans and cola, or we could get hamburger, baked beans and lemonade. We could get hamburger, fries and cola, or we could get hamburger, fries or lemonade. We could also get a hamburger, sweet corn and cola, or we could get a hamburger, sweet corn and lemonade. Now let's suppose we get a veggie burger instead. We could get veggie burger, beans, cola, veggie burger, beans or lemonade. Veggie burger, fries, cola, or veggie burger, fries, lemonade, or veggie burger, sweet corn, cola, or veggie burger, sweet corn and lemonade. Here are all the possible different outcomes. Part B. Write down the fraction of the meal deal that includes baked beans. How many possible options do we have in total? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 possible options, and those that include baked beans, we've got 1, 2, 3, 4. So we have 4 out of 12. And if we were to simplify this fraction, we would end up with 2/6. Question number 10. Two supermarkets A and B have special offers on the same packet of biscuits. Supermarket A, the normal price is £1.50 each packet. We've got a special offer: buy 2 packets at the normal price and get a third packet half price. Supermarket B, the normal price is £1.60 for each packet. We've got a special offer, 10% off the normal price. Dan buys 1 packet of these biscuits. Which supermarket is best value for Dan? Well, if we take a look at A, that costs £1.50. And if we take a look at B, we need to work out 10% off £1.60. So we've got 0.9. Now this 1.9 corresponds to 10% off the normal price. And then we multiply this by £1.60. So the price in B is equal to £1.44. So which gives better value for money? Supermarket B is cheaper because it's cheaper by 6 pence or £0.06. Part B. Darcy buys 3 packets of these biscuits. Which supermarket is best value for Darcy? Show how you decide. If we take a look at A, we can calculate the price. So we get £1.50 for each packet, and we've got a special offer. If we get 2 packets at the normal price, we get a third at half price. So we've got 2 times by £1.50, and then we get another one at half price. Half price is the 75p. So this 0.75 would correspond to the third packet being half price. And then for calculating this, we get £3.75. And for B, we have one packet being £1.60. We get 10% off the normal price. So what we need to do is use this price here of £1.44. And then what we need to do is multiply this by 3 because we want 3 packets. So if I work out what this is, we get £4.32. So which one is cheaper? A, because it's cheaper by 57p. The difference between 432 and 375 is 0.57. Question number 11 here is a function machine. We have an input, we times 4, we subtract 3, we get an output. For part A, for the first part, we have to find the output when the input is 10. So we have 10 for our input. What we do after this is we times it by 4. We then subtract 3 from this. So we have 40 subtract 3, which is equal to 37. Next, we have to find the input when the output is 17. So we have our input I, we times this by 4, we then subtract 3, we get an output of 17. So if I take the 17 and add 3, we have 4i equals 20, and if I divide by 4, the input is therefore equal to 5. Part B, the input is x and the output is y. We have to write an equation for y in terms of x. So we take our input, which is x, we times this by 4, we then subtract 3, we get an output of y. So our equation is y equals 4x subtract 3. So we have y equals 4x subtract 3. Question number 12. Kai has a bag of marbles that are red or blue or green or yellow. Kai takes a marble at random, recalls the colour and returns the marble to the bag. Kai does this 800 times. The table shows some of the results. Part A, complete the table to show the number of times a yellow marble is taken. To work out the relative frequency, we do the frequency divided by the total frequency. Now the problem is we don't know the frequency for yellow. That's what we need to find out. So we've got yellow over 800, which is equal to 0.47. And what we have to do is find out what yellow is equal to. That's equal to 376. So we have 376 for yellow. Part B, for the first part, there are 40 marbles in the bag. We have to work out how many blue marbles are likely to be in the bag. The probability for blue is equal to 0.1. We throw the marbles 800 times and we get 80 blue. So we have 80 over the 800, and then we are told we've got 40 marbles in the bag in total, which means we have 4 over 40. And therefore, how many blue marbles are likely to be in the bag? That's going to be 4. Is your answer to part BI likely to be the actual number of blue marbles in the bag? Give a reason for your answer. No, because it's an estimate for the actual number. Question number 13, part A. All of the loaves in a baker's shop cost the same price. Rowan buys 3 loaves and pays £3.78. Asmi buys 5 loaves. We have to work out how much Asmi pays. If we know that 3 loaves is equal to £3.78, we can find out the price of 1 loaf. That's equal to £3.78 divided by 3. So if we work this out, we have £3.78 divided by 3, which is equal to £1.26. 1 loaf is £1.26. And therefore, 5 loaves is equal to 5 multiplied by 126. So if I multiply this by 5, we get £6.30. 5 loaves is equal to £6.30. Part B. Alex and Ling travel the same distance to school. Alex walks to school in 20 minutes. Ling runs to school at twice the speed that Alex walks. Find out how many minutes it takes Ling to run to school. Well, if Ling is running at twice the speed, it will take half the time. And so therefore, the amount of time it would take, we would have 20 divided by 2, which is 10. It takes 10 minutes. Question number 14. An integer between 70 and 80 is written as the product of its prime factors as 2 times 3 times f. We have to find the value of f and the integer. Well, f needs to be a prime number. So let's try out different combinations. We've got 2 times 3 times 5, and if I work out what this is equal to, we get 6 times 5, which is 30. That's not in between 70 and 80, so we can reject f equaling 5. Let's now try 2 times 3 times 7, sir. 6 times 7 is 42. Again, this is not between 70 and 80. We can reject f is equal to 7. Let's try 2 times 3 times the next prime number 11. 6 times 11 is 66. 66 is not in between 70 and 80. Let's try 2 times 3 times the next prime number 13. We get a value of 78. 78 is in between 70 and 80, which means the value of f we are after is 13, and the integer is 78. Part B. 98 and 147 are written as the product of their prime factors. 98 is equal to 2 times 7 squared, and 147 is equal to 3 times 7 squared. What we have to do is work out the highest common factor of 98 and 147. So we've got 98, which is equal to 2 times 7 times 7, 7 times 7 is 7 squared. And we also have 147 equals 3 times 7 times 7. What's common to both? This 7 is common to both. This 7 is also common to both. So therefore, the highest common factor is 7 squared, which is 49. Question 15. Part A. 10 squared is written in words as 100. We have to write 10 to the power of 4 in words. 10 to the power of 4 is 10,000. We can confirm this on our calculator. We have 10 to the power of 4, which is 10,000. In words, we have 10,000. Part B, we have to work out 3.5 times 10 to the negative 1 times 100. Let's type this into our calculator. We've got 3.5 times 10 to the minus 1, and then we're multiplying this by 100. It turns out we get a value of 35, and if we were to write 35 in standard form, we have 3 times 10 to the power of 1. So we have 3 times by 10 to the power of 1. Question number 16. A bowl of dough is left to rise before it is baked. The graph shows the height of the ball of dough over the first 20 minutes. The height of the ball of dough in centimeters is given along the vertical axis, and the time in minutes is given along the horizontal axis. For part A, we have to work out the gradient of the line as a decimal, giving the units of your answer. Show how you work out your answer. Well, the change in x is 20 minutes. The change in y is 4 centimeters, so the gradient is 4 centimeters divided by 20 minutes, which is 0.2, and our units are centimeters per minute. For part B, a baker works out the height of the ball of dough at the end of 25 minutes as 14 centimeters. Use your gradient to show that the baker could be correct. Well, from 20 minutes to 25 minutes, we've got an increase of 5 minutes. And from 13 centimeters to the 14 centimeters, so currently we're at 13, we're going to 14 centimeters. That's an increase of 1 centimeter. So the gradient in this case is 1 centimeter divided by 5 minutes, which is the same as before, 0.2 centimeters per minute. So because we've got the same gradient, the assumption that we've made is they are rising at the same rate. Question number 17. Frankie draws a circle and works out its area in centimeters squared and the circumference in centimeters. The answer for the area is 2 times the answer for the circumference. We have to work out the diameter of the circle. You must show you working. Well, the area of a circle is given by pi times by the radius squared. That's the area of the circle. So the area in centimeters squared of the circle is pi times by the radius squared. The circumference is equal to pi times by the diameter. Pi times by diameter represents the circumference of the circle in centimeters. And the answer for the area is 2 times the answer for the circumference. So what we need to do is multiply the circumference by 2. And at this point, we would have to find out the diameter. So, we've got pi times by the radius squared equals 2 pi multiplied by 2r. And this 2r is the diameter. So we've got pi times by the radius squared. Now 2 times 2 is 4. So we have 4 pi r. Now the pi's would cancel on both sides. So we have r squared equals 4r. R squared subtract 4r equals 0. If we now factorize, we have r multiplied by r subtract 4 equals 0, in which case r is either equal to 0 or r is equal to 4. So the radius is 4 centimeters, which means the diameter is twice the radius. So we have 2 times by 4, which is 8 centimeters. So the diameter is 8 centimeters. Question number 18. The graph shows the solution to this pair of simultaneous equations. 2x plus y equals 14, x plus 2y equals 13. Use the solution to work out the value of 3x plus y. You must show how you work out your answer. Well, the solution to this simultaneous equation is where the graphs intersect. And they intersect here. They intersect with coordinates 5 across and 4 up. So we have our x value being 5 and our y value being 4. So when we come to work out 3x plus y, 3x plus y, the value of this when x is 5 and y is 4, we have 3 times by 5 plus 4, 15 plus 4 is equal to 19. So we have 19. Question number 19. Triangle A and triangle B are drawn on the coordinate grid. Describe fully the single transformation that maps triangle A onto triangle B. Well, what is happening over here is we are rotating the shape. So if I join up the corresponding points, we are rotating the shape and it would have a center of rotation here at 0, 2. And so therefore, we have a rotation with center 0, 2, 180 degrees. Question number 20. PQ is equal to 3, 2 and QR is equal to 4, 1. We have to work out the value of PR. So PQ is 3, 2. QR is 4, 1. The vector PR then is the sum of these. 3 plus 4 is equal to 7. 2 plus 1 is equal to 3. So by vector addition, the vector PR is equal to 7, 3. Question number 21. We have to solve x squared subtract 4x subtract 165 equals 0. We need two numbers which multiply to give negative 165, and which add to give 4. We have 11 and minus 15. So when we factorize, we have x plus 11 times x minus 15 equals 0. So this gives us solutions x equals minus 11 and x equals 15. So we have minus 11 and 15. Question 22. A recipe for a batch of jam needs 3 oranges, 5 lemons and 1.5 kilograms of sugar. A cook uses the recipe to make lots of batches of jam. They use 16 more lemons than oranges in total. Find out how much sugar the cook should use. So we've got the ratio oranges to lemons to sugar being 3 to 5 to 1.5. We can double this, giving us an equivalent ratio of 6 to 10 to 3. And if we represent this using this diagram, we've got 6 parts for orange, 10 parts for lemons, 3 parts for sugar. We know that we have 16 more lemons than oranges, so the difference between these is 16, meaning each part is equal to 16 divided by 4, which is 4. So for sugar, we have 4 plus 4 plus 4, giving us a value of 12. Question 23. Sam and Taylor are playing a game against a computer. They can win, draw, or lose the game. Sam says, I think the probability of us winning the game is 0.3. Taylor says, I think the probability of us losing the game is 0.75. For part A, we have to explain why Sam and Taylor cannot both be correct. Well, if I add the probabilities of winning and losing, we get a value of 1.05. This value is greater than 1, which is why they both cannot be correct. Remember, probability adds up to 1. For part B, Sam is correct. The probability of them winning the game is 0.3. Taylor is not correct. The probability of them losing the game is actually 0.55. We have to complete this partly drawn tree diagram to show all the possible outcomes of playing the game twice. So, probability of winning is 0.3, probability of losing is 0.55. Remember, probability adds up to 1, so the probability that they draw is 1 subtract 0.3, subtract 0.55, which is equal to 0.15. So the probability that we draw is 0.15. As we see here. For part C, we have to find the probability of them winning the first game and losing the second game. So, they win the first game, but then they lose the second game, as we see here. So, to find out the probability that they win the first game and lose the second game, we have to multiply the 0.3 by the 0.55. So we have 0.3 multiplied by 0.55, and if we work out the value of this, we get 0.165. So we have 0.165. Question number 24. The scatter diagram shows the number of visitors to a children's playground and the maximum temperature on 15 Saturdays in summer. That's what we see here. For part A, we have to describe the type of correlation shown in the scatter diagram. Well, as we can see, as the maximum temperature increases, so does the number of visitors, and therefore we have a positive correlation. Part B. One Saturday was hot but stormy day. We have to circle the most likely point on the scatter diagram for this Saturday. Well, what we are looking for is an outlier. So we are looking for a high maximum temperature but a low number of visitors. That would correspond to this point here. So when we come to explain why we chose this point, well, simply, it's an outlier. For part C, we have to use a line of best fit to predict the number of visitors on a Saturday that has a maximum temperature of 21 degrees. So what we want is a line of best fit which roughly goes through the same number of points, such as what we see here. Now what we are looking for is the number of visitors given a temperature of 21 degrees. So 21 degrees is here. So we would have to draw a line up, and then we draw a line across. You can see we've got 62. So we've got 62 visitors. Question number 25. A child has 4 identical wooden cubes of side length 6 centimeters. Part A, they arrange the cubes in a 2 by 2 by 1 arrangement to form a cuboid. We have to show that the surface area of the cuboid is 576 centimeters squared. Well, this line here, we've got 6 centimeters plus another 6 centimeters, which is 12 centimeters. The depth from here to here will also be 12 centimeters. And then we have the height here to here, that's just going to be 6. So what we can do is find out the total surface area. For the surface area, we would have 12 multiplied by 12. So that's the bottom face. And then we have that face at the front. So that will be 6 multiplied by 12. And then we also have the 6 multiplied by the 12 here. And then we need to add these up together and multiply all this by 2, because we've got the front, the back, the top and the bottom. So if we work out what this is equal to, we get 576 centimeters squared. Next, the child arranges the cubes in a 4 by 1 by 1 arrangement to form a different cuboid, as we see here, and we have to calculate the percentage increase in surface area for this cuboid compared with the 2 by 2 by 1 cuboid. Well, if we do what we did before by calculating the corresponding lengths, here we would have 6 plus 6 plus 6 plus 6, which is 24. Here we would get a length of 6, and here we would also have this length of 6. So for the surface area, we would have twice, because we've got the front, the back, top and bottom, left and right. We would have 6 times by the 24. Then we would have the 6 times by the 6. And then we would have the 24 multiplied by the 6 here. And then we need to add these together. So we've got twice 6 times 24 plus 6 times 6 plus 24 times 6, we get 648. So for the percentage increase in surface area, what we would have then is 648, subtract the 576, divided by the 576 multiplied by 100. So it turns out we get 12.5%. So we would have 12.5%. Question number 26. Triangles ABC and DEF are mathematically similar. Triangle ABC and angle DEF are equal. That's what we see here. We've got AC being 25 centimeters and BC being 15 centimeters, FD being 10 centimeters and ED being 7 centimeters. We have to calculate the perimeter of the triangle ABC. Well, we've got the triangle DEF, and if I take this and rotate it like so, so the angles match up, and if we then proceed to stretch it, you can see how the triangles are similar. So let's go back a step. We've got this 7 centimeters here and this 10 centimeters here. So if I rotate it, what we can do then is see what the corresponding sides are. This 25 corresponds with this 10. So this and this match. We've got this 15 centimeters, which corresponds with this length. And then we've got the 7, which corresponds, 7 here corresponds with this length here, like so. So now what we can do is calculate the scale factor. The scale factor is equal to 25 divided by 10. So 25 divided by 10 is 2.5. And that makes sense. 7 times 2. We can multiply this 7 centimeters by 2.5 to get the length here. So 7 times by 2.5, that's equal to 17.5. So here we've got 17.5 centimeters. So therefore, for the perimeter, we have 25 plus 17.5 plus 15 which is equal to 57.5 centimeters. So we have 57.5 centimeters.